Have you ever really, truly thought about how we measure things? I'm not just talking about the length of your desk. I'm talking about the age of an entire galaxy, or the impossibly quick vibration of a single atom. Well, let's get into it, because today we're going to unpack the incredible system that humanity invented to get a grip on a universe of absolutely mind-bending extremes. So let's start big. I mean, really, really big. This is what scientists call the macro world. Take a look at our neighbor, the Andromeda Galaxy. We think it's been around for about 10 billion years. That's a number so huge, our brains can't really even process it. Okay, now let's do a complete 180 and snap to the other end of the scale, the micro world. A single cesium atom vibrates over 9 billion times every single second. So the time it takes for just one of those little vibrations is, well, it's a fraction of a second, so ridiculously tiny, it's just wild. So how? Seriously, how is that even possible? How can we, as a species, measure something that lasts for billions of years, and at the same time, measure an event that's over in a billionth of a second? That right there is the big question we're tackling today. To even begin to answer that, we first have to get our heads around the sheer range we're talking about. We live in a universe that is, at the same time, unbelievably huge and almost invisibly small. I mean, just look at these numbers side by side. It's kind of nuts. You have the Andromeda Galaxy with its 10 billion year lifespan and a diameter measured in kiloparsecs. That's a unit you only break out for galactic level distances. And then all the way down at the bottom, you've got a cesium atom existing on a timescale of billionths of a second and with a size measured in picometers, which is just an unimaginably small slice of a meter. So science basically splits this reality in two, right? You've got the macro world, that's our world, with trees and animals and planets, where we measure time in seconds and years. And then you have the micro world, the world of atoms and molecules, where time gets measured in nanoseconds and space in nanometers. Two totally different realms. So how in the world did we manage to bridge that gap? You know, we didn't evolve with eyes that can see atoms or a sense of time that can feel the age of a galaxy. Nope. We had to build our own technological supersenses. We had to build a toolkit. And this is where human ingenuity just, frankly, blows my mind. We came up with things like cesium atomic clocks for ridiculously precise timekeeping, and space telescopes like Hubble and Webb to see across the universe. And for the super small stuff, we built electron microscopes that let us not only see things at the nanoscale, but even film motion happening at the nanosecond level. These tools are literally our super senses. But here's the most amazing part. The part that sounds like science fiction, but is absolutely real. All of that incredible technology, and in fact, every single physical measurement we can possibly make, is all built on a foundation that is shockingly simple. 7. That's it, just 7. Every single physical concept we can measure, the speed of light, the density of a star, the heat of a fire, it can all be described using just 7 fundamental building blocks. These are what we call base quantities, and honestly, the best way to think about them is like the primary colors of physics. You can't make red by mixing other colors, right? It just is. Same idea here. These 7 things are fundamental, you can't break them down any further. And here they are. This is basically the Rosetta Stone of modern science. It's called the International System of Units, or SI for short. You've got your basics, of course. Length is the meter, mass is the kilogram, and time is the second. But then you also have the ampere for electric current, Kelvin for temperature, the mole for counting atoms, and the candela for how bright something is. Everything starts with these 7. Okay, so if those 7 are the letters in our universal alphabet, how do we start writing the story of the universe? Well, simple. We combine them. And that brings us to what are called derived quantities. It sounds fancy, but it's not. A derived quantity is just a new measurement you get by multiplying or dividing the base units. Just like you combine the letters CAT to get the word cat, you combine base units to get, well, everything else. Let's just build one. Let's make speed. How do you do it? Well, you start with one base quantity, length, which we measure in meters. Then you grab another one, time, which we measure in seconds. You just divide the distance by the time and bam, you've created a totally new derived unit, meters per second. It's that beautiful and that simple. And the exact same logic works for area, force, pressure, you name it. So what's the big takeaway here? This beautifully simple system of 7 building blocks isn't just some neat trick for scientists. It is, and I mean this literally, the foundation of our entire modern world. This system is a genuine universal language. It means that a scientist in Japan, an engineer in Germany, and a manufacturer in Brazil are all working from the exact same rulebook. It is the language that makes global teamwork possible. And that is why this all matters so much. Every single piece of technology you rely on, from the smartphone in your pocket to the GPS that guides your home, it only exists because we all agreed on this shared, incredibly precise system of measurement. It is the invisible framework that lets us do everything from build skyscrapers to launch rockets to Mars. So that leaves us with a really fascinating thought to end on. These 7 units define our physical reality as we understand it right now. But as our science pushes into brand new territories, things like quantum computing or information theory, what might we discover that just can't be described by these 7? What's going to be the 8th base unit?